So my name is Corey Smith. I'm here to talk to you a bit about external attack surface management programs today. We're going to talk around the area, not get into too many specifics, but why is this related to cloud security and what we're here to talk about for this conference. So a bit about me. I've been in the cybersecurity space for over 20 years now. I started out over at Symantec, went and did some stuff with WebSense, partners, been in the sales side, run solution architecture groups, been a consultant, been doing this my entire career, okay? And this specifically is one program over the last few years that I've felt has become incredibly important to what we're doing in the cloud as well as what we're doing as organizations in general. So I'm going to talk a bit about the problem. I'm going to set you up with Dave, okay? Dave is a cartoon that I had from like 10 years ago, and it still rings true, unfortunately, today. And I'm going to show you a few examples of things that Dave has done, including one cloud example that should tell you what some of your users might do to you out there. I'll talk about the fundamentals of the product lines that are kind of in the space. Give you some ideas for some tools and processes to kind of work into your workflows and give you a bit of time to possibly answer questions at the end. If we run out of time for questions, I am here at the conference over at the Qualys booth. Feel free to grab me and have a conversation with me about any of this stuff if you have questions. So defining the problem before we jump into my funny part and Dave. The problem with external attack surface management, how many from a show of hands have a person on their team that's specifically responsible for external attack surface today in your organization? Do I have any hands up? Maybe one or two? Okay. As you move into the cloud and everything now has a public IP as it's kind of connected back to your infrastructure, you're really going to want to take a look at how these tools work and help do attribution of these assets to yourself. Because the traditional IT tools or traditional vulnerability management scanning isn't always going to catch everything that we can find using these different techniques and tools that are out there. The concept of an unknown unknown, that's when we get into the shadow IT type realms. We've got a guy that, I've got an example where he spins up a whole bunch of infrastructure in AWS, okay? How do we detect that today? It's your company information that he's purporting out there. What tools do you have in place that can find that? Moving into a lot of this stuff, reconciling your assets back and forth, I would ask, but I'm pretty sure I'll get the same answer, which is that for most of you, you may have a CMDB, but the confidence in its accuracy is probably very low, right? So how do we help curate some of that data going in and out of the CMDB and help you identify what assets are publicly exposed to the internet? And a lot of this stuff gets siloed. You've got different groups and different teams doing different things. I talked to the CISOs yesterday about maturity, which is the ability to deliver a consistent, repeatable, effective practice in cybersecurity. You may have groups, or you may be part of one of the groups that's doing something in the cloud today that's probably at that maturity level where it's consistent, effective, and repeatable. But a lot of the other groups are not at this point. So how do we get this expanded to cover everybody that's inside of your orgs? And one of the other pieces, too, as I realize the chairs are a little bit in a different spot than they were yesterday, there's a lack of centralized controls to give you some information, to be able to roll things up into a central view for everything. It's really hard if you're running multiple cloud solutions, too, as far as if you're in Azure and AWS, or if you're in AWS, GCP, OCI, and now I've got China assets, and I've got Alibaba involved, and I've got some stuff going out of Europe with IBM. It's a lot more difficult to get that centralized pane of glass. So let's talk about Dave, okay? This was a cartoon. It came out years and years ago, and Dave is labeled as human error in this case, but it's not always human error that drives what Dave does, okay? We have spent tons and tons of money on security, and everybody still clicks on the damn OK button and not cancel when they get that pop-up from the phishing email, right? Okay, so the end user and our people and our process that kind of go around that, no matter how much technology we put in place, there are always aspects of things in the business that we have to address. So if we move into this, just a couple of the Dave-isms that I've found for stories to kind of set things out there for you guys to think about. The first one that I come up with is this one. This is the customer names have all been anonymized. These are all things that I actually witnessed happen at a previous organization, to Qualys. One was the Fargate example. Dave was an IT manager out of Hong Kong. He was a new hire. They were posting out containerized applications that would just spin up in Fargate. and Dave didn't get his account provisioned for him, and they had a problem provisioning the account, which is one of the core tenets of cloud security is, of course, your identity access and being able to automate all of that stuff. So that was one of the problems that company had. His GM was getting really fed up with the fact that he couldn't get this marketing site operationalized when everybody else already had it, right? It's typical internal politics. The other guys like to give the guy that's behind a bad time. So Dave, being fed up with hearing about it, goes and throws his corporate credit card down on an EC2 instance, brings up the container images, but he screws up and he misprovisions the storage and leaves an allow all rule on it. Who do you think found it first? The attackers or Dave? Right? Okay. This happened about 5 years ago, so if you go look in the news stories, you can probably find that one. That's one example. Another one that we had that Dave, did. Dave won a contract for a really large software manufacturer, building their corporate headquarters up in Toronto. This is a little less cloud-centric and a little bit more about the external attack surface management, kind of the stuff we bubble up in here. Their building is fully automated. Everything is connected to the internet. Now, what we find happens a lot of times in these cases is the leasing company or the contractor is the one that actually plumbs in your automation system for you. And you have no idea what they've done with all this stuff. And in this case, the guy was very helpful, talked to the facilities people at this large software company. They said, just plug it in and then send us the password for it when you're done. Okay? Facilities told him that at the company. So he went and grabbed TELUS, ran a cable modem out there, stuck a static IP on it, labeled it literally the BAS system for software company name that has been redacted. Toronto headquarters. Okay? We were contracted to go and find stuff like this and went and found this. We did give him bonus points because he did use a slightly complex password, which was the company name 123 exclamation point. Took us about 10 minutes to break it when we did this. And we were able to control everything that was inside of their building at that point. Now, luckily, there were no people actually in the building yet. It was still about to be opened at the time. But it also led into, for you guys as security professionals, it became a game of, who's on first type of thing. We told them about the issue. The security team referred us to facilities. Facilities referred us back over to security. Security told us to sign an NDA and sign up for the bug bounty program. All because their building automation control system was hanging off of the internet and we told them about it, which they had asked us to do. Turned out they went and fixed it afterwards, but it took us almost a month and a half of this thing being exposed before anything was done with it. So for a month and a half, that was sitting there. The last one that's kind of something that I had happen as well, I love the wiring closet. How many people's wiring closets look like that? You don't have to put up your hands. I don't expect you to answer to that. Dave was a contractor at a large government agency. Dave was hired to come in and recable and fix all the mess that was going on. Dave lost a couple of labels while he was pulling cables. And rather than try to trace them back or go and get some clarification on which switches these were supposed to go to, he just grabbed the random ports he thought they were supposed to go into and plugged them in. And unfortunately, he managed to find the one network that was actually part of the it was the secret network for this agency, and publicly exposed it to the internet because it actually DHCP'd a public address and allowed it to broadcast out to the world for 6 hours. The company I was at, we found it 4 hours later at the time. But for 6 hours, the entire secret network for a really large government agency was sitting publicly exposed on the internet. Okay? Again, nothing that Dave did maliciously, right? These are not malicious users. These are just crap that these guys do by accident, not thinking about it. So how do we detect this stuff? So let's move into a bit about what EASM is actually about. EASM gives you all these different pieces. I'm not going to read the slide to you. There's all sorts of different vendors that are doing it. Shodan is probably the one that most people have. How many people have Shodan logins here? A few? Okay, Shodan's probably the one that's most known. Census is another one. Qualys, we just made an announcement that we've got stuff going in there. Palo Alto's got their version. They brought people. You've got Psycognito. There's a few others that play in the space from the available to everyone. Try not to be specific or biased towards what we're doing specifically, but there's a bunch of them that are there, and they're all kind of following this piece, which is looking at your domains, the subdomains, the who is registrars, and trying to call back and give you a way to view data that might relate to yourselves. So, The goal of this being to identify your previous unknowns. How many of you have done at least one M&A activity in your company history? How many of you actually ensured that that M&A company is either fully underneath your current IT banner, or that none of their IP space is still sitting out there registered to that activity? We find this all the time. You know, you can do a simple who is search for any of your company names of things you've acquired over the years and find IP spaces probably still sitting out there that may be registered to somebody that's no longer at the company, or it may be re-registered to somebody that's already squatted on it. We do find a lot of squatting that happens on those if they've expired. So somebody may have grabbed an acquisition target of yours to try to do malicious activity with it. So you're going to want to find this stuff. That's one of the core tenets to doing external attack surface management, is identifying the IP space that should be yours and ensuring that you're doing something with it to either get it out of your name or it's fully managed underneath of your name. You know, these things we find live IPs. You know, we found in one case for a company we did this for, we found a server that was still sitting there with a web service actively running 10 years after the acquisition happened, right? Nobody had ever turned it off. It was sitting in a building somewhere, and nobody had ever found it inside of all the wiring closets it was buried in. So this stuff does happen. It's prevalent. The next piece on this is you need to understand the context of these assets once you do find them. So anything we do here to help you work and find these assets, we need to give you better context around what the assets are. This includes like the full discovery path. So any tools that you use for this need to tell you, hey, we found it from the whois registrar over here. We did this through a DNS scrape. We found these different pieces that are the DNS entries that are associated with it. Here are the individual IPs. Here's the end user that says they're registered to it. So you have the full context when you go to do your investigations, right? We need to show you the hosting providers as well. So if this stuff is being hosted in current cloud providers, we need to tell you who the IP spaces belongs to. Because if we don't see the hosting information, because the only way to see if it's actually, you know, EC2 or Azure is usually through authentication to the EC2 or Azure instance in the first place, right? Then we can pull the APIs, we can pull the information back. Or if we've got an agent on the machine, we can pull the information from the local APIs and the machine images. But if we're just looking at things from an external perspective, we're just going to be going off of the IP and the DNS address to try to do the attribution of where this thing is sitting at. So you want to make sure that whatever you're using can figure out the IP space that's owned by Azure, AWS, OCI, IBM, all the rest of them. And then from there, we want to identify the potential security gaps and close them up, right? A lot of times, as part of this, we'll find unsanctioned services and ports that are still sitting open on machines. You know, if we're running a web service, you know, hopefully you do not have database services on that same machine, so the database ports should not be open. We shouldn't be able to hit any additional high ports on that machine, you know, things like that. We should be looking at the certificates. You know, often I see certificates that expire and it costs, you know, companies different amounts of issues. You know, regardless of e-commerce, it's just the fact that now all of a sudden when I go to your site and I've got to click the proceed button because it's not trusted, that's kind of a problem. And look for potential vulnerabilities as part of this too. You know, on the external attack surface side, we're not doing authenticated scans like you would normally do with a standard vulnerability scanner. We're trying to pick up what we can infer from what's visible to us on the internet. But we should be able to identify some of the vulnerabilities that are popping up out through there. And the last part of this too, and I talked a lot to your CISOs about this, is review all your IAC code that's going through your automation in the cloud. How many of you are using Terraform or CloudFormation today? Okay. If you're using Terraform or CloudFormation, one, you want to use it everywhere that you can. Because the easy part of this is, once I get Terraform and CloudFormation rolled out to everything, I can now audit the network and say, what is deviated away from what I originally spun this up with? Okay, those functions are built into Terraform, for example, where you can actually tell, does this thing have any difference or drift from what I originally put this thing out there as? So now if I can read the script, and this is my automation script to go and spin up any infrastructure in AWS, I can infer where everything is at that is in the same security state as this one. So we have no misconfigurations, we don't have extra rules that are opened up. And so it's incredibly important that as part of any of the stuff that you're doing and looking at these external attack surface, look at your IAC that's spinning these machines up in the first place, because it'll give you a wealth of knowledge that you can then use to track things. Going from there, you want to monitor and reduce your risk across the entire attack surface. So we don't want to just focus on the IP addresses. We don't want to just focus on the machine images that are out there. We need to take a look at containerization, right? You should be looking at all the different containers that are running in your environment and gain visibility into what the workloads are like. More often than not, as security professionals, when I ask most of you guys what you're doing for containers, you refer me to the DevOps guy. And that's something that we're going to have to change over time of, getting more visibility and more understanding around what the container guys are doing, what the DevOps team is doing, so we can better protect and help lead more of these conversations in regards to what security architectures need to be implemented. One other thing I'll point out too, on the multi-cloud side, trying to detect things across multiple different cloud providers sometimes gets to be very interesting. Each one does it a little bit differently, gives you different levels of automation. So you need to look at the tools that you're trying to bring on board, giving you those capabilities across all the different cloud providers you might be using. Because if it's great in AWS but sucks in GCP and all your developers run stuff in GCP, you're going to have a huge blind spot. So making sure that you're taking into account the multi-cloud strategy that your DevOps team may be putting into place is really core to selecting any tools you use in these spaces. So with that, I'm running a couple minutes ahead, so we might be able to take a couple of questions. Just a quick recap. Anybody that's in the cloud should be looking at external attack surface management at this point. Everything that you're spinning up probably has a public IP address on it. And you do want to be able to track all that information and see what attackers might find out about you. Monitor the attack surfaces beyond weekly scans of your known IP space. Right? A lot of people have been treating this, we're at Qualys. I hear this all the time. I'm using you guys, why do I need this? Because scanning something on a weekly basis is not sufficient to understanding what your attack surface is. That just gives you a sense of what the vulnerabilities may be in those machines at that point in time. So trying to get that visibility down to at least daily, if not a couple of hours, is extremely important with this type of tool set. And don't forget to review your automation. Because if we look at the maturity levels of organizations and how we measure maturity, that comes back to repeatable, effective, I forgot the other one. So in order to get to that maturity level, if we don't have automation, we're not going to get there. And if we're not reviewing our automation, we're still blind to what's going on inside of those organizations. So thank you guys very much for their time. I think we got about a minute and a half here. If there are any questions, I'll open it up very briefly. One, do we have a mic?
Thank you. Hi, my name is Chris Wilder. I'm with Charles Schwab. You mentioned something about the containers. Mm-hmm. Do you consider the containers fall within the infrastructure as code, perimeter, or policy as code?
What was the second part of not the infrastructure, what was the other one?
Policy as code.
Policy as code? It kind of depends upon which part of it you're trying to assess, right? Because you've got the application side, which is one sort of assessment. The infrastructure as code kind of applies to it as well, because we're going to want to look at the YAML file and figure out what it's doing. But it's more so, it falls into both, right? I would look at both the policy side of it, for violations of what there's there. So, is it a root level container? Let's make sure that we're not spinning up root level containers. Let's make sure that our secrets are protected and encrypted. But then also we need to look at the vulnerabilities on it too and look at what all makes up the container in the first place for the software packages. So ensuring you've got a clean, bill of materials of what the software is, and making sure that, the other thing that we kind of find too on the Qualys side is to ensure that the software packages on that container are only the ones you need. Because if they're not being run, why are they there, right? We should try to depack those containers so we're only putting packages on there we actually need. And I do find that happens still, as everybody's kind of new to the container space, they're not always building them to a best practice of the minimal software configuration that you would need to make that run. I don't know if that fully answered your question, but okay. Any other questions? Otherwise, I've hit 0. All right. Everyone, thank you. Again, I'll be at our booth if you need anything else.